Hello, ladies and gentlemen. I haven't streamed since I can't remember, since I worked on Caddy. Got the website set up at least. I bought a domain name. I bought some server space. It's like the cheapest server they had for $2 a month, and I got a little website set up. Let me show you. I bought the natekilo.com domain space and made a little bit of a JavaScript code to drive a software renderer, see where the mouse is, etc. I tucked the, it's still a work in progress, but I tucked the engine wasm into another page. You can probably access it. I'm pretty sure you can access it. Just type in natekilo.com. You can see my GitHub. I mean, I don't really post much stuff on there. My YouTube, yeah, all that shit. Pretty cool. So that's what I've been working on. I got that set up this morning. I've been really busy with I slung my resume around to a bunch of places, and I'm actually getting interviews. So I've been shocked, and I've been busy working on that. But I figured I wanted to brush up on my language programming skills. I wrote I followed along with crafting interpreters. Just pull it over. Crafting Interpreters. What a great book. I did this last year. And yeah, I wrote the first half of the book is in Java, but I converted it to C for like my own makeshift version of his language. And then I followed along with the stack-based language for the second language. And then I got curious and started writing my own register-based language, which I made a previous video on. But we're just gonna do it all over again. So we're gonna start with writing a little parser where you can scan text with it. So I guess we'll just get started. I'll show you how to set the whole thing up. You need the C Windows build tools. I made a little bat file, so this is what it looks like. You want to, the goal for this batch file is to open up a VS Code window that has access to the build tools. And this is what you can do. You can call this stuff here. I can never remember the whole string, so I just copy it between all the different batch files. And you open up a folder, and then you call code on it. So we're gonna make dir in the C directory lang test, and then we'll go to it. So that opens up a little folder. We have this batch file for it. Let me double click it, and it'll open up that folder with VS Code. And here we go. Here's a new little folder. Do langtest.c, and we'll just get started. Let's include stdio.h, stdlib. Let's do int main, printf test. And see if it compiles. You can do Control-Shift-B in VS Code, and then you can choose the build options. I think that should work. Yeah, okay, that'll give us a bunch of files. And, I can initialize this repository, and we can git ignore all these other files. All we care about is lang test right here. So that should get us started. Now, well, let's just see if we can run it. Do C++ Windows, do whatever that does. Cool. So you can see it's printing out that test thing. So we're going to do fputs. I think have it open over here. I can never remember the commands for fputs. So you do like I don't know, lang test. Why not? Lang test, and then a little caret there. Set it. No, we got to do std out. Yeah, that's it. Let's just see if that works. Let's run it. Yeah, cool. Okay. Now we can do fgets. Well, we need some kind of input, so we can do char input. Max it at like 2048. Do input, max count 2048, and then stdin. Yeah, and then we can just do fputs again. Can we do that? No, let's just print the whole thing out. std out, yeah. Then lang test, test. Cool, okay. So we have input. Now let's just start writing the parser. So we're going to do parser. We're going to pass in input, and then we will get started. Okay, so where do we even begin? We're just parsing text right now, and a parser takes in some kind of information and cuts it up or transforms it and like reads the semantic data from it. I don't know what the definition of a parser is, but that's my mental model of what it does. If that makes any sense to you. So I guess we can do char c equals, let's do like I don't know, why not? Input I guess we could do a for loop. Or, no, let's just do while input I does not equal the terminating character. And let's just print everything out one by one. C. Then we'll do C equals input I plus plus. Or plus plus I. Yeah, sure. Why not? Let's just see what happens. Alright, so we print out hello. Okay, cool. So let's do, I don't think we have bool. We can include boolean.h. std bool.h, is that it? Yeah, okay. We could do that. Or we could just, I don't know, like, why not just make everything integers and we'll just return 0 or 1, right? So we'll make is alpha. And we'll pass in a char. And we'll do if c is greater than or equal to a and c is less than or equal to z. In the ASCII table, these are just values. Characters, chars break down into integers. And in the table, you have a stretch from a to z of subsequent numerical values. Can't remember. Let's look up the ASCII table. Look up a little picture. Okay, here you go. So over here you see, starting at 65, you have capital A all the way down to capital Z at 90. So we could do the same thing, like if it's greater than or equal to 65 or less than or equal to 90, but when you type in that character, like A or Z, you get the same results. And then we can do the same for lowercase. Then let's just say is alpha. Just print out all the data for now. Make sure that we're doing everything right. Pass in C. Whoa. So you can see that they're all alphas. Let's type in some numbers. It's alpha. Cool. Cool. Make sure the stream is still working. Yeah, cool. Okay. So we got alphas. Let's do int is num. Let's do the same thing. Char c. If c is greater than or equal to 0 and c is less than or equal to 9. Return 1. Otherwise, we'll return 0. Then we'll do the same thing. Do is num. Okay, so we got alphas here when we do hello, and then numbers here when we do 1, 2, 3. And the last space we can do int is white space. You got to skip all the white space when you're parsing stuff. Depends, but we're gonna skip it. I guess we could do a switch for this. Then you have the new line character. Return 1. Default. Return 0. I can just side of all this. TR space. That should cover everything. Like to make it look all clean. There we go. Then we can just do one final task is white space. Let's just type in some gibberish. Yeah, I probably shouldn't type in gibberish, but you see we still get some results for white space. So that's pretty cool. You can see the tab character right there. So that should give us everything we need. Now I guess we can start trying to read for the semantics of whatever we're reading in, I guess. So should we do like parsing position? Yeah, why not? Per parser, I don't know, parser. Sure, why not? In case we need it later. So we do type def enum token type. Just do token none for now and see if that compiles. Parser is not a function. Oh, oops. I call it the same thing as our function. Just call it cursor. Type def struct token. I can never remember this, why you need to do that in C, but there you go. You need to do that. Then you also need to do a union. Let's just call it integer for now in case, depending on what the data is. Or offset, yeah. Token type. Okay. Let's make an array of tokens. Let's just make it global. It doesn't matter. Tokens 2048. Int token count equals 0. Is there something else we need? What kind of tokens do we even have? We can have like integers. We can have characters. We can have bools. We're gonna make the eventual goal is to make a C-like language. I like C. I like basic C++. I'm most comfortable with those, so might as well just try and replicate minimal versions of them. We got int char bool. I don't know, let's do a plus, minus, slash, star. You missing anything? We do equals. Semicolon. I don't know if we're not gonna get to half of these today, but left paren, right paren, left curly, right curly. I don't know. That should probably cover everything, and then depending on the token we have, we can make it an integer, we can make it an offset into an array, we can do like char var storage, call this 2048, int var storage offset. We could just point to the location in the text that we're reading in where that variable name is, but I'd rather just store it so we can make it easier to print it out. Because this whole piece of memory will be, we might need to set it all to 0. Let's just do that real quick. Let's do memset var storage, set it all to 0. And then that whole array will just be a huge block of null terminators, so that as we scan like text or variable names, we can jam it in there to make it easier to print out, because printf terminates on the null terminator. Yeah, tokens, input tokens, okay. Yeah, let's just figure out what we need to do to parse a number. So, just get rid of this. Oh, that's weird. Just comment that out. Let's do switch C. Did we do that, or no? Let's do an if statement. If is num C. So we'll just see if it's a number. If it is, we can do val equals 0. And while, I don't know, is num C. And then we can advance, or C equals input plus plus I. So every single step of this loop will advance to the next character. Are you walking? Yes, I'm walking. I got a little treadmill. We're writing a parser on a treadmill, a little treadmill. You can get a cheap walking pad off Amazon for like 80 bucks. It makes programming so much better. You should do the same. Standing desk and treadmill, it's like less than 200 bucks these days, and it's well worth it for your health. So, we're trying to parse a number. So, again, while we're advancing through the text, we're going to keep checking if it's a number. We're going to have this little value thing, and then we can do, if it is a number, I think to get the numerical value of it, we subtract, we do C plus equals C minus the value for the character of 0, and that'll like offset it, because in the ASCII table, how can I explain this? Where are the numbers in the ASCII table? Yeah, right here. So decimal is 48. So you have the character of 0 in the text input. You subtract the value of the character of 0. 48 minus 48 is 0, right? You have the character for 1 in the ASCII table, which is 49. 49 minus 48 is 1. So by subtracting by the character of 0, you can extract the numerical value of that text, if that makes any sense. So that's what we're doing. And then we can shift it up. So val times equals 10. Or do we do that before? Yeah. Yeah, I think we want to do that before. I don't know. We'll figure it out. We'll just print out the results. So printf val. And we'll see what happens. Okay. So we will give it 100. And val is 100. So we can extract text at least. Let me test 100. Val 100. Okay. Let's just keep testing. Okay. Cool. We can I don't know. Yeah. So those are our numerical values that we're now extracting with the parser. And what we want to do is, I mean, we could make a function for it, but we'll do token t, we'll initiate a new token, we'll do type equals token number, we'll do t.data.integer equals value, and then we'll do tokens dot token count plus plus equals t, and that will append a new token. I thought it was value. Oh yeah, val. Still, we got errors. T.type token number undeclared identifier. So we can have integers, characters, booleans. Let's just make it an integer. We'll see what happens. It's not my first time writing a parser, but you always forget stuff when you spent a few months since you wrote your last language, you know. Token integer. So let's also write something like void print tokens. And then we'll do for int I equals 0. I is less than token count. It's that global that we declared, plus plus I. We do a switch statement based on the, let's Let's do token t equals tokens. Switch based on the type. Case token integer. I like to structure my switch statements like that. Like denote the sequence that the token is in. Token number, let's do the type, which will be token int. So we just do it like this. And then we'll display the value. Please, yeah. t.data.integer. Compiles, I did something wrong, as usual. We gotta input the I there. Okay, so once we parse, let's just print out the tokens. Print tokens. Let's do 100, 200, 300. So now we have tokens 100, 200, and 300. We'll just do a little I+1 here just that we can, I don't know. It doesn't really matter. But you see that we start token 0. Yeah, let's just keep it at token 0. Why not? Okay. So we have numbers. Let's do characters. Let's scan for text now. We should probably skip white space as well. So if it's a number, if it's white space, I guess we're skipping it. If is alpha C. Do the same thing here. While is number, let's do if. Let's set up parsing errors now. So in parse error, we'll just start it at 0. So and we can evaluate it as a bool. If it's 0, then it's going to be false. If it's 1, then we will set it to true, and we can do if parse error printf error in the code not evaluate. I don't know. Not evaluating. Cool. While is alpha. If it's alpha, while is alpha. Just do the same thing here. Copy that over. If, oh yeah, so if the next character is an alpha, we can do parse error ++ through printf. I don't know, like you probably meant to declare a variable name, you know, in a, you don't want to do, let me just give you an example real quick. Just comment this out. We'll do int 1 test, right? This won't compile because the parser, you know, it starts reading it, it thinks it's a number, and then you put text in there, but you can do test 1. And so we're going to try and mimic the same behavior. So as soon as we finish parsing a number, if we hit an alpha immediately after, then we'll just say invalid variable name cannot contain numbers first. I don't know. Parse error. I called it parse error. And then we can return from there. Cool. Okay. So we'll do is alpha. We can also do is num. If it's alpha or numerical, then we can interpret it as a variable name. We'll start with that. So we will just do and start equals var storage offset. That's another global. I should probably denote it with like G underscore to make it useful for you, but it doesn't really matter. So again, we're reading in text. Right now we're just evaluating if it's a number or a variable name. And so this is where we're going to evaluate if it's a variable name or a keyword or something like that. And so, how are we going to do this? I guess we can do var storage at var storage offset plus plus equals C. I guess we can just hit the end of it. Oops. And then we'll do token T, initialize a new token, token type equals, let's just call it a variable name. Let's go back up to the top and do token var. Page down. Oops, where are we? Token var, T dot data dot var offset equals start. And then we can just print it. So printf token var equals, we'll just print out the string for it. And this is why we store it separately, just to make it easier to print it out. So do T or var storage, then in that array, well, we want, if we did it like this, that would give us the character, so we want to get a pointer into that string. And then we would do t.data.var offset. Just to print it out, right? Okay. So int var equals 100. Token var equals int. Okay, so we skipped the first one. Interesting. Plus plus I. Let's just step into it. So, character, let's watch this. It's I. Var storage equals, oh, I never actually store it. That is weird. How is that even, did I accidentally delete that and not see? I guess we'll find out. So, it's I, int, okay, yeah, that's weird. Let's try it again. Okay, int, var, token int, token var. Okay, cool. So we can store stuff like that. But if you noticed, we think integer is a variable name. And we don't want to do that. It's a keyword. So we also have to check for keywords. If it's alpha, yeah, I can do that. So we'll see if it's like a reserved keyword. So first we'll do if, I don't know, is keyword. Keyword, please. Do input plus I because we want to scan the string. And if it's not a keyword, we'll store it as a variable. So we'll get started on the keyword thing. Let me just print keyword found. Just a little placeholder. Get started on is keyword. Then we'll need to do a pointer. Is keyword must return a value. Let's just return 0 for now, assuming nothing is a keyword. So how are we gonna do this? I guess we can start. We'll do char c equals, we'll dereference the string right here. Like that, and then we'll switch based on what it is. Do a little thing called a tree. This is called a tree. T-R-I-E. It's like a branching thing. Or instead of like looping through and checking every possible combination, you can be a bit more performant. I don't know, just Google it. This is my conception of a tree. I got it from Crafting Interpreters, probably in the parsing chapter. Is this it? No. Where did I put that book? That little bookie book. Yeah, so scanning, it's probably right here in chapter 4, Crafting Interpreters. This is where I learned it from. But what you're going to do is we can make a little switch statement. We can do if, let's do C equals I. This is the beginning of integer, right? And so then we can do while while C equals like const char int keyword equals int. We already checked for the I in integer, so now we just check for the nt, and then we just loop through it. So int keyword at, I don't know, let's just do step equals 0. We'll do a thing called match. We'll assume it's a match, and then we'll step through the whole thing. If it's not equal, actually, we do a little for loop. I equals 0, I is less than. Let's do int size. We're going to break it down in a second. I'm just trying to remember how we're going to do this. Make it all clean. Leave it messy for now. I equals 0, I is less than size, I plus plus. If C does not equal int keyword at I, I'm going to set match equal to 0, and break. And we just do match right here. Return match, set it right here, int match equals 1. If we started at 0 and then we set it to 1, if we detect that it's a potential match, yeah. Int keyword match equals 0. Okay. And then we need to update C every time. So we can also do C plus, like dereference. Stir plus 1. We'll dereference string, we do plus 1 to get the next one, plus the step. Why not? Plus 1 plus step. We'll just wrap all that up. And I also starts, yeah, we'll just do plus I plus 1. I think that should work. And then we'll just run it. We'll just type an int, and it did not work. Let's find out why. Int, let's go to keyword. C is I. Oh. Well. Why did that happen? Let's try it again. C is I. Switch based on C. Oh. That's because we need to do case. Case I. Okay. Still doesn't work. What's wrong now? Case I, step 0. I guess we didn't really need step. Size 2. I think I'm not doing something right. Let's see. Stir. Something in my throat. Plus 1 plus I. God. 106. Can I convert it to a char? Let's do char. J. Yeah. What I actually want to do is I want to increment the pointer, and then we'll dereference it only after. Yeah, let's see if that's better now. Nope, not quite. There we go. Okay, keyword found. Okay, that's perfect. So what that means is that we can now check for keywords. Oh yeah, okay. And what do we want to do? I guess we can just be sloppy and like in here we can set the token based on the keyword found and then increment the cursor. We can always clean it up later. I'm gonna be sloppy and fast for now. Need some water. Okay. What were we doing? Man, I really don't like that, but it's nice and compact. We can do char c equals. Why not? Let's do c equals star plus 1 plus I. We'll just do c. If c does not equal that. And then we can do keyword match. And we'll send in the string and the const char. What is this? Compare. And then we'll do a size. Return 0. We'll set the match equal to 1 while just copy all this over. Size, string size, keyword, break, just return. Yeah. You need to set match to 0. Just return 0 right away, and otherwise we'll return 1. Compare. It's not a keyword, it's compare. C, declared. Okay, so we need char. Yeah. Yeah, this should work. Keyword match. We'll give it stir plus 1. We will give it nt and 2. And that should handle it. And man, still wrong. Int keyword. Oh. Match equals. Man, doing something wrong. Let's see what's happening. Keep breaking it. Okay, what is string right now? What is C? T. Do I plus 1. Oh. Yeah. Guess we can leave out that plus 1 for now. I mean, where do I want to do this in the pipeline? I just feed at the beginning. I should either know to increment it in the is keyword, or I could do like match. I don't know. Let's just see what happens if I leave that out. Okay, keyword found. Okay, perfect. So we can check for int. Let's do a few more cases. Let's do like bool and char. Here's b. For bool, just to give you an example, do OOL. That's 3. Do char. C. This is also going to be 3. Char. Let's do like true and false. True and false. Yeah, it's not alphabetical. Who cares? True is going to be 3. RUE. Else. 4. Okay, just a handful of keywords. And then we can start returning the type of token that it is. Why did I do an inflection on my voice there? Int char bool plus minus slash equal to like true and false. Why not? True and false. It's a token type. We can return what it is. If how do I want to do this? I can turn into if statements. Compiles match. Turn type. No, not. Token type. Type equals token none, which is going to be the same as 0 because that's the first entry in our enumerator right here. It's the same as 0. Do we need to do anything? Like, I guess we might as well use curly braces. Then we'll do type equals token false. True. Char. Bool. Int. And why don't we just print out, let's like have a big function right here that returns const char token stir token type takes t, do switch based on t, and then we'll just print out every possible value there could be. Why not? Then otherwise we'll just return something empty, have a default case. We're going to need to update this with all the other tokens that we eventually add, but for right now, we don't really care. So we'll do case, space, then I press end, so you can jump to the end of all of these, backspace, semicolon. I guess doesn't really matter what comes after that, right? Control arrow to go back. Okay, and now you just do return. Oops. And then we'll just push all those in again. We need to get rid of all the commas. Let's straighten this out. Just pressing tab to push these around. Your editor may vary. Just to line it all up. commas. Ooh. Okay. I did something wrong. What did I do? Oh, it's because we forgot semicolons. At the end of this, right here. There we go. It's still wrong. Break. What's the problem? Semicolon. We're returning something, then we break. Do we not want breaks? Man, something like this always happens. Did we forget a semicolon somewhere? Let's just comment it out and see what happens. Okay. Let's enable one of them. That's still working. Okay. This is the problem. How is this problematic? Oh, it's because I have this colon right there. Okay. Hey, look at that. Okay. So we'll get back the type. And we'll do is keyword. If it's a keyword, let's just print out the type. A little string. Then we'll do token stir. Do token type is keyword. We're going to need to run this on every single one anyway. Put plus I. So if it's a token, then the type will be non-zero. So we could just do is type. Otherwise, it'll just be a variable. So we do int char bool test true false. Okay, we're getting there, but now we need to start skipping because of the way that we designed this. Now we need to have a switch statement in here based on the type. There's probably a way to do this better. Kind of lazy about it. So we'll just get really sloppy. Well, we'll definitely want to store it. Token T. Yeah, type. We'll want to push back whatever kind of type it is. And we'll do tokens, token count, plus plus. It's T. And then inside here, just copy all the tokens again. Why not? Add a default. Let's make it pretty. Oops. Oh God. Oh God. Try that again. To do this in VS Code, I'm holding Control, Alt, and then an arrow key to make a multi-line cursor. No, I don't want to return. I want to do t.type equals that. Then we're going to push it back. Okay. Cool. And then we're going to do the same thing. We're print tokens, and then we're going to have a whole nother mess like this. Why not? We're just going to keep doing this over and over until I think of a better way. Oh, God. You can also hold the middle mouse wheel and drag it up or down in VS Code. Ooh, that's nice. Break. I want to add a default. In case I ever want to compile this to WASM, it'll give you errors for unhandled cases if you're forgetful, so I just like to throw in a break all the time now. And then we'll do, just add a little print right here. It's not an integer. Just do token here. Token none at D. And that should be good enough for what we want. And we'll just throw this in. Not Control V, Control C. No, sorry, Control V. Then we will paste it right there. Okay. And we're getting something because, of course, we're getting errors. Yes. I have too many curly braces right there. Okay, so let's see what happens. Toke and test. Oh yeah, okay, so in this, I also forgot that depending on what you read in, we need to increment the cursor because, you know, at the bottom over here, we're doing ++ I, so we also need to increment it. Otherwise, when you read token, you're going to find the keyword. Well, no, it'll read as a variable, so then you do int k. So as soon as you read I, all we do is we consume that I in the buffer, and then we start at n for the next loop. So we just want to offset I here. It's kind of sloppy because it's also going to depend. Do I++, do like 3. Also, we read in 2, none. I don't know, that's not really going to matter. We don't want to compare against none anyway. And this is also sloppy. So we read I, we read NT, so that's 2. We read C, we read har, that's 3. 3, 2, token variable, we don't care about that. Token plus, we don't care about that. We only care about keywords here. So we're just going to do true, false. Okay. And so now let's just do that same thing. Token int test. Token int. Okay, we're getting there. Forgetting something. You read token. Switch type. Is type. That's interesting. So we're reading token. This is T. We're going into input. True. Type is, please get the type. 0. Yes. Good. Okay, good. Okay, so then we interpret it as a variable. We store it. Next loop, it's an alpha. It's I. We got integer. Good. And then C should be a white space. So we increment it. Yes. And so it's white space. Skip that. It's going to be true. Is it? No, it's going to be test. Okay. Yes. At the end, let's go into print tokens. We're going to have variable token. Token count is 1. Okay, so we never incremented token count. Switch. Tokens, token count T. We stored the type right there. storing it? Oh. Let's see. Forgot to do that. We forgot to push it back right at the end there. Okay, let's try it again. Store these tokens. Okay, so we have a variable. We have an integer at slot 1 for tokens, and we have another variable. Let's do some more printing. Yes. I want to make this line up with the rest of it. Why not? Okay. So if it's an integer, then we're going to print out the value. Otherwise, if it's a variable, we'll print out the string. We'll do t.data.var offset var storage plus. Yeah. Okay, just make it all pretty. Okay. So the text that we enter is going to be talk and test. You see that the first one is a variable that we store. Oh, okay, so we overwrite it. We do test. It's interesting. That can't be good. We got a little bug. Integer token int. Oh. Okay, I just wrote a bunch of bugs into this. If it's an integer, I don't really know how we're going to want to design this language, so there's a lot of stuff we can choose to do or not to do in the parser. I can just make a number token. Yeah, I'll just add a number token for now, token number. And that's how we'll store. Because int, like, we'll just have another variable name, right? We don't really need to do anything for int. This is just a keyword. This is just if we found the keyword. Break. Number here, t data, token num. Yeah. I want to figure out why we're printing out test twice there. Our storage offset equals 0. How did that get there? Maybe that's our problem. Okay. Talk test, test. Okay. That's because after we loop through everything, you want to increment one final time. Because remember, var storage is allocated with a bunch of zeros at the start. And because we're not leaving any space in between all the variable names, we're just going to print out the whole thing. So like, I can give you an example. Like, this is going to print out all the token variable names. And so you can see it right there. This is going to print out all the token variable names. And so what we need to do is, as soon as the loop is over, we just need to offset one more time. So that'll push us into a terminator, a null terminator space. So that now when we do it, if I compiled it, now you can see this is going to print out all the token variable names. So got that to work. Maybe like, I don't know, I only anticipate having like a maximum of three decimal spaces for the token count, just so we can make it look all pretty instead of having this offset over here. What next? Yes, okay. So we want to store it as a number. Oh, please. No. And now, int test, okay. Let's run it again. 1, 2, 3. Okay, so we have variable, token, we have an integer, which is just the keyword, variable, which is test, and then we have numbers 1, 2, and 3, and those are all tokens. So that looks about right. Of course, what happens if we have a bunch of white space? Okay, nothing. It just skips all the white space automatically. So this is a really clanky parser, but it's working for our use cases. So we're testing is number, is alpha. We could do, I guess we could do else if. Why not? It doesn't really matter. Do it right there, I don't really care. And then we'll do else if it's not white space. So now we'll have a bunch of cases. We could do switch, C. We can have a case like it's a plus symbol. For example, break, store the token, t.type, do token t. Let's just put this all in one line. Token t, new token, t.type equals token plus. Not really any other data associated, so we can push it back, token count, plus plus. And then we'll add a few of those. Token none. Okay. Because, do we have a plus? Yeah, plus. So we should be printing it out. Token t, t.type. Do we ever hit this case? I guess I should break it up into multiple lines so we can step through it. Let's try it again. C is the plus symbol. T.type. It's plus. We're gonna, oh, we never push it back. Okay. Oh god. I did like Control Shift and? Oh yeah, that's a new window. Okay. I only ever do Control Shift B. Try all that again. Okay. Token plus. You see that down here? So I guess we can just collapse it for the time being. Let's do token minus token slash for division, token minus slash star. Okay. This will be the minus, this will be the slash, this will be the star. And I never, oh yeah. Minus slash star. Okay, plus plus minus slash star because we did two minuses. Okay, so that's a parser. We can break it up into tokens now. Okay. So now I guess we're going to want to start evaluating what those tokens mean now that we have the basic parser. And this is where I start to get lost. So we can open up crafting interpreters, wherever it is. I had it open in a tab somewhere. Scanning. Okay. So you can access this book now. Of course it starts in Java, but it is good practice like to try and convert the Java code that you see. Oh, sorry, I didn't see all these comments. Okay. Won't linter help? Probably, but it behooves us to know how to write this all from scratch. I was also building Elixir thinking I could make a whole programming language. Turns out I underestimated it, only ever finishing the easy part. Are you loading the whole target file in RAM or using a buffer? Oh, so you're not using a file for now. Type defing enums is diabolical. Yeah, I'm used to C++, like very minimal C++, so in that you can just do enum type, and then you're good to go. And that you can also do like struct token, and you don't need to do any of that other fancy stuff. So yeah, it's just some C bullshit that's going on for that. Is linter a library? I've never used it. This is like the 5th parser I've written. And I mean, depending on your use case, yeah, you might want to use a library. You can write a programming language. Like I wrote one. I have a video on it. Caddy VM test. Yeah, it's in this folder. So I wrote a virtual machine, like from scratch. I guess I am including a few libraries like stdio. It's in C++. And so you have like it's basic assembly, and then I have all these tests for it. This is the virtual machine where you parse the text and you break it up into a bunch of instructions, and depending on those instructions, the virtual machine does something. And I also heavily sandbox it, like guard against any out of memory accesses so that you can't crash it, because if you crash it, then the whole program crashes. These are the tokens to strings that I wrote for this little project, and then I have a bunch of tests for it. I show all this in a video I wrote, in a video I made a while back, like a few weeks ago. I'm trying to find the tests. Yeah, so like here's where I like work with the stack in the virtual machine I made. Here's where I test like labels, where like you can jump between functions. I mean, it really depends on what you want the programming language to do. The intent for this one is to make a magic system in my game that, I mean, it's going to be assembly code for now. I mean, it's if you want to get good at the game, then you're just going to need to learn the basic assembly VM that I wrote. But why I'm doing this right now is it would be cool to write a higher level language that I can then break down into that VM text that you saw. So that's the end goal for this. Yeah, you could use linter, you could use other libraries, but if I want this to run on your machine without you needing to have all this bloat from other libraries, then I can just write my own minimal, good enough code. I stress test it for all the inputs you could possibly throw at it and make sure it doesn't crash, and then it'll be good enough. So, yeah, big long-winded way to say, yeah, it depends on what you want to do. You can use other libraries, of course. But it's good practice to just crank all this out and to know the whole system end to end, So that's why we're doing it. So, I can't remember where we were. Thank you so much for commenting, by the way. I really appreciate it. Sorry, I only look over like every 10 minutes. But now we're at the point where we can start interpreting what it all means, and then we'll have rules for whatever token comes next. So I guess we could just try to evaluate something like, an example, int, I don't know, test equals 1, right? And so that'll give us 3 tokens. Oh yeah, we never parsed the semicolon, which we want to use to end statements with. So we'll have an integer, a variable name, and a number. That's pretty cool. Let's also add in a semicolon. Where do I do that? Yeah, right here. Oh yeah, so we're also going to want to add in like left and right parentheses, semicolon, semicolon. Let's get the spacing on that decent. Semicolon, left, right parentheses, left, right curly brace. Let's just do all that real quick. Oops. Okay. Token, left parentheses, right paren, left curly, right curly. Make sure it compiles. Let's add those in. Yeah, cool. Okay. Just a few more tokens. Yeah, so the minimal test that I want to get set up for now, we're going to write it very wonky, and it probably won't be scalable, but just to remember a little bit, let's just try and brute force it. And I'll give you some time to think. I got to piss. I will be right back, ladies and gentlemen. Bear with me, please. Okay. So, what we're going to do now is we're going to try and evaluate it a little bit. Like, we have the tokens. We've extracted tokens from the text with the parser, and now we want to extract some kind of semantic meaning from it. Like, knowing that this variable has this value. So, yeah, there's a lot to do. It's hard to keep it all in your head, you know? So, there's a bunch of different things we could do. We could do recursive descent. We could write a Pratt parser. Again, this is the holy grail of all programming languages. You should absolutely reference this. Like, once you have the parser, of course he does the parser in a better way. This is all Java, by the way. I think it is, yeah. I think this is Java, right? And so, of course, you can convert it all to C. Then he has all these other things. This is much more robust, etc., etc. And then, I think one of these chapters, it's written by Robert Nystrom, by the way. Cool guy. He has, like, I think Handmade Seattle had him on for an interview in, like, 2022. Where he talked about this. I've never watched it, but I do love this book. This is the tree walking interpreter section where you build an AST, an abstract syntax tree. And you can use that for either seeing the layout of the code, and you can also execute it too with recursive descent. Control flow, parsing expressions, evaluating expressions. Yeah, let's go here. We parsed some expressions representing values, evaluating parentheses, truthiness and falsiness. Yeah. Let's, you know, I don't want to read this book on stream and remember how it all works. So we're just going to try our best to brute force something. And so we're going to, from what I remember about the book, we're going to have like an expression. And because it's C, you need to forward declare it like that. Def struct expression. Expression. We're also going to need to type def enum expression type. Do expression none. Expression value. Yeah, I guess that's good enough. And then we can have expression type here. And of course, get an error because, yeah, okay. So we have the expression there. We can do type def struct. I guess we're writing a recursive descent parser, an abstract syntax tree, because we're going to have, it's recursive in nature. It's going to keep stepping further and further down and linking all of these expressions against each other into an abstract syntax tree. We absolutely will not get that far. I'm going to build a totally busted one because I can't really remember, without looking at my other implementations, how to do it all at once. So, just for practice, we're going to try and rediscover it on our own based on a flawed, forgotten understanding. So we're going to do value expression, and then inside we'll have a token T, and then we'll have a union right here, union data, and then this will contain the type that it is, so right now we'll just have value expression. Okay. And then we'll need to have some kind of global array of expressions, so we can do expressions, 2048 of them. We'll do int expression count, set to 0. Okay. Cool. So I'll have a value. Yes. So I guess we can store data in the value expression as well. And we can do integer. Like if it's an integer token, then inside the expression we can actually set it to something. And if it's a value, I guess we'll also store like an offset into the variable, so var offset. I don't know. Just gotta experiment. Okay. We'll do print tokens, and then we'll do, I don't know, construct AST. And then we'll have expressions. Really know, we'll have like a program thing. We'll have pointers, program. And this will store pointers to expressions that we parse, and then we'll have like program count for later when we want to execute it. If we can't execute it, and you know, you might want to make like a statement thing. I think Nystrom's book gets into that. Anyway, let's do construct AST. Without further ado, construct AST. And then we'll loop through all the tokens. For int I equals 0, I is less than token count. I guess, yeah, depending on the flow, this will be, bear with me, this is, dude, 6 viewers? That's crazy, bro. That's crazy. We're at the worst part now. This is going to be the worst part of the stream because now I'm out of my depth and I have no idea how to construct the AST or even how we want to begin. So you're going to bear with me. If you have recommendations or if you want to read the book to give me hints about what the hell I need to do, then go for it. But all we're trying to do, again, is to, oops. We're just trying to get something like store an expression for integer, you know, integer test equals 1. We're going to try and store a value into a variable that we set as a type integer. And I don't think I've done this yet. Like, I've written the abstract syntax tree based on Nystrom's language, where you don't even have types like integer or bool. It's just values like, you know, JavaScript or Java. So I've never done types before. Yeah, and then the third language I wrote, that was just, that's an assembly-like language where you assume everything is an integer. So I've never written a higher level language like this. Blah, 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 whatever, no one cares. Token count. Or cur token or token next token? God, let's just call it current token, right? And so then, oh, we should also add an end of file token, token EOF, just a signal that we've hit the end of the data. And so in the parser, yeah, we've written a ton of shit. Let's just add EOF. EOF. End of file token. And then once we hit the end, we can just append a new token. Call it token T. T.type equals token. End of file. And then tokens. Token count plus plus equals T. Let's see what happens. We run it now. Okay, so you can see at the very end, now we have token EOF. So what we can do in the construct abstract syntax tree, we do while tokens, I can do like token T equals tokens cur token, while T does not equal token end of file. Or token none, I don't know. Just as a little extra assurance. T.type. Not equal. Okay. So now this will start us looping through all the tokens. This will give us the first token. We can do at the very end t equals tokens, cur token plus plus, or plus plus. Yeah, right there. So we'll start evaluating it. Then we'll do if t.type equals integer, then we're going to have a rule for that. Let's just add printfs like integer found, scan forward for variable name. Right? Let's add the position that we found it at. Again, you don't need to do all this. I like adding copious amounts of printfs to debug as I'm stepping through. And then of course it eventually gets unwieldy, and that's where you do stuff like define debug 1, if debug, else, and if you do like a print debug. Same for p debug dot dot dot, and then you do printf bar args. Is that it? Oh. I had it somewhere. Where was it? I got started on this because I was interested in writing a Lisper, so that's why I could just crank out the parser, because I basically did that whole thing like yesterday. So it's fresh in my mind. Printf VA args, that's it. Let's just minimize that. VA args. Still not right. Do I need to do the semicolon? VA args. No, this is the wrong one. Printf. Yeah, isn't that right? Define. Oh, yeah. I need to define this. Okay. Hey, there we go. And now it's working. Okay. So now instead of printf, you like print debug, p debug, then you can have that. But of course, because it's set to 1, everything will still print. So, but you can set it to 0, and then you'll stop getting all of the printouts. So that's a little trick you can do with preprocessors in C. If you want to learn more about anything C related, and just watch Handmade Hero by our Lord and Savior Casey Muratori. You just Google it, Handmade Hero. That's how I learned basically everything. So where were we? So if we have an integer, we want to scan forward. Let's do void peak token, and then we'll return a token type. Then we will return tokens, cur token, next token. I guess we can do like int next token. Man, I just don't know. How do we want to do this? Yeah, okay. Cur token. We'll do cur token plus 1. And this will return the type for the next token ahead. Right? Okay. And so we can do if peak token, where we give it cur token, equals token var just printf expected a variable name following int type. Cool. And I guess we'll have a, I don't know, int processing error. We'll increment that processing error. Plus plus, and then we'll just return. Okay. Make sure that compiles. So, current token, we peek the next token, it's a variable. Construct AST. How do we want to do this? We can construct value expression, like expression, return a pointer to it, make value expression, do e equals expressions, expression count. This will create one, expression.type equals expression value. Is that the right type? Yeah, expression value. Can I convert? Oh yeah. If we access it with brackets, then that would give us the actual, that would assign it. We want to just get a pointer into that array. What am I doing wrong? Syntax missing. E.type. Yeah, that's it. Oh yeah. And because it's a pointer, we want to do that. Cool. Let's see what happens. We're experimenting here. Make a little expression thing. Dot data dot value. We're accessing it as a value expression. So we do dot data or pointer data dot value, and then inside of it we can store that token, the value of the integer, var offset. Yeah. Yeah. Trying to get it all right in my head. Can I open this? Copy into new window? And we'll like try and drop it. Yeah, of course not. Whatever. Value.data.integer value.t value.var offset. Equals this will take us to the next token. Offset.data.var offset, right? Make value expression must return a value. That is because I never return a value. Let's return E. E for expression. .data value var offset. Just to print out the variable name when we're debugging it. Let's do that right now. Assigned to int type. I don't know, assigned. I don't know why I'm doing all caps. Current token. Let's do var storage plus the offset that we just set it to. Let's just see what happens. Let's just run it. And cool. Okay, assigned test variable name to integer. We just did int test equals 1. Okay, so we're getting somewhere. We have assigned the variable name to the integer. That's good. That's a nice step. And so then we're also going to want to set the value. And we'll need to do peak token. Do we just want to keep nesting it? Yeah, let's just keep nesting it over and over. Peak token, cur token, and this will need to be token equal because we're going to want to assign it to something. If we see, we will just assume for the language right now that if we see int variable name we're going to want to assign it to something. So we are assuming that there will be an equal sign there. And if there is not, then we will give an error, get another nested error, and say expected assignment operator. Operator following int var name. Yeah, why not? We'll do the same thing. Okay. That'll be another error that we need to check for. And then we can do tokens current token dot data dot integer, because we will assume that it's an integer. If it's not an integer, it'll be a number. It'll be a number token, and the number tokens have a integer thing associated with them. Blah, blah, blah. What's in the value expression again? Value dot t. I guess we could set it to that number token, and then might as well just copy over the integer as well. T equals, right? And then dot data dot integer equals. This is just stupid, but why not? Let's just do dot integer or dot data dot integer. Yeah, okay. No, that is going to be that's an equal thing, so we can step over that. And then after that, we're going to need another error case where now we're expecting a number. This is really brittle. Really brittle. Token, else, printf, error expected, number token after equals token for, and just copy all this over. Okay. Yeah. Ooh, this is getting ugly. We can always clean it up later. This is not the final state of it, obviously. Okay. Okay. Assigned value to int, and we'll just do that. Yeah. Var storage. And then we'll just do the integer twice. Or we can just do int value value. Okay, let's see what happens. Let's run it. Okay. Expected assignment operator. Okay, that's because we never store the equal sign. Do we even have an equals token? We do have an equals token. We need to look for it. Right here. Token equal. Token count. Okay, is that all we gotta do, or is there more? Hey, assigned 1 to int test1. Okay, perfect. So now, in that expression, Tenebris, hi. Dan KM7IL. Is this C? Yes, this is C. We are programming in C. This, at the start of the stream, we made it totally, like, this is, you can go back to the start and you can see me incrementally build this. So we started from a parser. Now we're trying to construct some minimal abstract syntax tree from this, very sloppily. I don't want to spend like the next 3 hours pulling from Robert Nystrom's book, this wonderful, beautiful book, Crafting Interpreters. I cannot sing its praises enough. This will teach you so much about making programming languages. I stumbled on it last March, and I wrote a few programming languages out of it. And recently I wanted to brush up on how it all works again, so I can't really remember how to make robust abstract syntax trees, so we're just brute forcing it right now and seeing how far we get. And so far, out of almost 350 lines, we can assign, oh man, this is ugly. We can assign values to integer variables. Yeah. Okay. So this will return how do we want to do this? We'll need to store the variable into, oh man, into a hash table. I'm learning C for cybersecurity. Am I in the right path? Yes, C is useful for any domain in computer science. So yeah, keep learning C. I've never done cybersecurity. I mean, let's do some cryptography now, because now we need a hash table. Because we want to store elements to a hash table. Let's just terminate this with a little semicolon, actually, real quick. So we're going to have, yeah. Okay, so this will fail if we have plus operators. Yeah. So we've already built a busted AST. This will not give us a correct AST because, what if you do, let's run it. What if you do like 1 plus 1 plus 1 plus 1, right? So we can only assign that first value. And so we're going to need to write a different loop to make an actual abstract syntax tree. I'll need to research it tonight, and I guess we can stream more tomorrow based on what I've learned. But we can at least assign a single variable now. And I'm really interested in low level and how exactly computers work, so I started with C. Yes, that's a great idea. Keep going with that. I can show you Handmade Hero. This will teach you everything you need to know. Got it? Why not? Handmade Hero right here. Just Google it. There's this guy, our beloved Casey Muratori. I think it's on hiatus, but for his 600 episodes, over 600 episodes, last one he did. When did this come out? Day 667? When did that come out? And 2 years ago, yeah. But he shows you how to make a whole video game from scratch, starting with a build system. All you need is the first 30 days. Yeah, like right here, up to day 30. And that'll get you started in Windows at least, and then you'll know enough to make your own game from there. But yeah, so stop watching me and go watch Handmade Hero, because I'm just fumbling. I'm flailing right now writing a broken parser with a broken AST. So we'll need to evaluate the plus expression, so we'll need to have like a binary operator. I can't remember how to do any of this. How about this? We'll just make a broken thing. I said we would make a hash table. Yeah, let's make a hash table. So we'll need buckets and stuff like that. This is going to be brutal. But I'll show you how to make a hash table at least. We'll need to use the, what is it, the INVO FM hash, something like that. FNV. Is it FNV? FNV hash algorithm. It's like some kind of Fowler-Novo hash function. Okay. So we'll put it in a little window right here. Oh my god, where was it? Okay, let's see if we can compile still. So we're gonna want type def struct hash entry. I guess we do hash, or let's add a define at the top. Let's do define U32 unsigned long int. Let's do signed long int S32. Okay, getting an error because I never put anything in here. We will do U32 hash. This is an unsigned long integer for a hash. Thank you so much for the advice. I'm not leaving. I'm having fun watching you. Well, thank you. Thank you, Tenebris. I appreciate it. This is going to be fun very soon. I don't know what your definition of fun is. So for the hash entry, we have a hash. I guess we can do char. We can like point to the name. We're going to hash strings. So we're just going to do that. And then we will make U32 hash string. We'll give it a string, char star string, and we will do U32 equals U32 hash, return hash. And then it's a specific string of data because this will have enough ones and zeros. I have it in another file. I think this is what you multiply it with. While I guess we could do string does not equal the null terminator. Instead of doing like this, that little null terminator, you can also do doesn't equal 0, but I mean we already wrote it, so who cares? So while we're not at the end of the string, we XOR it with the current character, and then we multiply it with this number. Oh, we need to start syntax error. Oh, the string does not, oh yeah, that's because. But I can't remember what kind of value you use, and I could just drop it in because I already got this. You just need to pick some value. I mean, it doesn't really matter. We can do like, you just want to pick some starting hash value to give you enough distributions of ones and zeros, but let's just do that. This is a broken Fowler null VO hash or okay. So this is how we hash our strings. It's 3 in the morning. Write it in binary. I mean, I guess we could do that. Yeah, why not? Why not? I guess we can do 1 0 0 0 binary 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32. Well, that compile. Okay. So that is a hashing function. You just want to have some kind of distribution of zeros and ones. And then you XOR it with the current character. And then you multiply it. And then that will give you some kind of unique hash that we can then use to access the hash table. Yeah, right? So we're going to make the hash table now, and this will be, we're going to make it out of hash entries. Hash entry, hash table. We're going to give it 2048 entries. Did I do that right? Oh, I should put this above all the globals. Hash entry. Get it to compile. Okay. And so we're also going to, we won't add buckets right now. That's just another thing we can get into. But hash buckets, because you do like hash table size 2048. Because you can also add buckets, hash buckets, hash table size. But we're going to ignore buckets for now. If you have a collision, you got to handle that on your own. The book will teach you one method of doing that. And so we can hash the strings. Let's do void push to hash table. And then we'll have the string. Why not? And so hash table entry or hash entry? I can't. Entry. They can do entry. We will do U32 hash equals hash the string. So we hash the string here. We get back some value that we can then do hash table size Oh god, what did I do? Hash table size -1. So what you're doing here, is this it? You take that hash and we want to wrap it. This is going to be a huge value, way above 2048, so we're going to want to wrap it somewhere between 0 and 2047. And you can do that with either the modulo right here, but if you do the AND operator, then, I don't know, Casey Muratori explains it better. But this is a little trick you can do for a faster modulo. Modulo isn't really that expensive nowadays anyway. Yes, yeah, we can just make that the hash. So this guards us against accessing the table out of bounds. And then we're going to see if these are all valid entries. We're going to check if hash table plus hash stir does not equal null. We're going to see if there's anything in this table first. If there is, if it does not equal null, then we're going to do printf hash entry error, table slot is already occupied. Otherwise, we can just push it into the hash table. We'll do a hash table hash equals entry. Let's do entry.stir equals string. We do this below the hash right here. Yeah, why not? Let's like wrap it. Let's put it below the wrap. Then we'll also set that to string. Okay. So this is a very broken way of pushing into a hash table. I have a calculus exam in 4 hours, so I have to sleep. See you tomorrow. Thank you so much for joining in Tenebris. See you tomorrow. If I do stream tomorrow, I don't know. I probably should. So this is how you do a hash table. Let's just see. So once we have all that, let's go back to our very broken abstract syntax tree constructor, where we assign that integer, and we will do peak token, not push to hash table. Push to hash table. You will send in that value. We'll do var storage plus var offset. This will give us the string that we want to push in. Okay. And let's just say debug pushed to hash table at entry u, since it's an unsigned integer. And we'll do string at hash. And we're getting an error because it did something wrong. Pdebug referenced in. Okay. Oh. Let's move this to the top. Okay. Okay, let's see what happens. Okay. Assign 1 to int test1. Push to hash. Set a breakpoint there. Push to hash table. Am I going forever? I think we're going to ever. Yes, we're looping. We're infinitely looping here. String is test. Test. Oh, we also need to do plus plus string to advance to the next one. Yeah. Yep. Forgot to increment it. Language test. Let's enter this. Let's step in. We hash it. We get back a hash value of something that will definitely not fish in the 2048 long hash table. We're going to modulo it. So now we get 34. The string is going to be test or 0. Oh, that's because yeah, that's because inside the hash string we increment the hash value itself. I guess to avoid that, we just do this. Int stir pause equals 0. Just do string stir pause, and we'll just do plus plus stir pause so that we avoid incrementing the string pointer. If that makes any sense. Gonna go there. Should be 34, and then we should see test. Yes, T for test. Okay, and the hash is 34, or rather 144. Did I misread it last time, or? That's interesting. Pause. Oh well, that doesn't matter. So now we enter it. Push test to hash table at entry 114. Okay, so now we have the variable loaded in the hash table, which will be our permanent / semi-permanent memory to access all the variables in the program of this programming language. And we'll go back to the abstract syntax tree where, of course, we go to the next token. And what is that next token anyway? T.tokens, where are we? Current token is 4. We did int test equals 1, 0, 1, 2, 3. This should be an end of file token, right? T.type is plus. Oh yeah, that's because oh no, I'm not doing any pluses, am I? Oh, I guess it cuts it off somehow. Yeah, okay, so then we have a plus symbol. So this is where you would actually want recursive descent, but I can't remember how to get that working, so I will need to read Robert Nystrom's book again. There's multiple ways you can do it. You can build an abstract syntax tree with recursive descent where you see the plus symbol and then you take the current expression and then you step into it. I guess we could try that. Let's just try it real fast. Let's see the plus symbol. Else. Okay. So right here where we get the value, we expect to see a token number, right? A number token. So right after that, this is going to get tricky. Let's just see if we can do this real quick. We're going to just see if we can chain together a bunch of plus one, and accumulate it into a single integer that we can then assign to the variable. Void binary op. I don't know. Because what we're looking for is a binary operator where you have x or like a plus b. There's two values here. There's a and the b. That is binary for 2. If you have, you can do like a unary operator. Void unary op. Uni for 1. And that's like if you do negative a, you're like inverting the value of a. So like a minus b, that's a binary op, but you can do like a minus negative a. That's a unary op. You can leave that there. It doesn't really matter. So we're going to scan for, I guess we can do recursion right here. Are you real? Yes, I'm real. Hello. I'm not AI. I'm a real live flesh and human being. I'm in a real life room. Yeah, I'm real. I'm walking on a treadmill. I'm doing my programming. We're constructing a it's not even an abstract syntax tree. We're trying to remember how I can't even remember the term for it. I'm blasted, dude. Recursive. We're trying to remember how recursive descent works when you're evaluating a language. We peek the next token. We see that it's a number. Let's just peek the next token. Let's peek another token. And if it is a plus, then we can do a binary op with the current token. Yeah, whatever. This is bad. Binary operator. Yeah, whatever. Let's just do it. This will return an integer. We're going to make a lot of assumptions right here. Going to do int value equals 0. We're going to add them all up in the binary operator. Yeah. T.value. We can pass in that integer value. .data.integer. That'll be the value that we start with. We're going to pass it into the binary operator. Yes. Okay. Again, this is broken. Return value, int value, int per token. Okay. Getting it to compile successfully. The next token will be a number. What we're going to assume, who's better, C or Python? It depends on what you want to do. Python, it runs Python's underlying machine. It's a virtual machine that Python runs it, and it's powered by C, C++. And so our Lord and Savior, Casey Muratori, he did, it's called Computer Enhance. Yeah, it's a great series. He moved to this after Handmade Hero, but the first episode is he shows you, and like, you can go to the table of contents. Welcome to Performance Aware Programming Series. In the very first lecture, you need to pay for it. It's great, by the way. It's like $9 a month, $7 a month. But in this episode, he demonstrates that to run any single instruction in Python, it's like 100 C instructions. So it depends on the performance you want. Python is vast. It gives you access to a bunch of libraries written by other people built into the language, but it's slower. And C, you need to either import libraries or write a bunch of code yourself, but it gives you like almost as fast performance as writing in assembly. So it really depends on what you want to do. I'm most comfortable writing in C, and I like writing everything from scratch. So you can do this. You can do this whole thing in Python. You could write a virtual machine. You could write a language that runs in Python. Like Robert Nice from his book, Crafting Interpreters, he writes this in Java. And the Java virtual machine is also implemented in C or C++, I'm pretty sure. And so you can just keep going higher and higher up the stack. Like you write this programming language in Java. So the underlying layer of the LOX programming language that's demonstrated in this book, under that is Java, and under Java is C. So you can do anything you want at any layer in the abstraction, but we're doing it in C because I'm stupid and I don't know Java. Yeah, that's why. I'm stupid and I don't know Python, so we're just writing it in C. So we got the value here. We can do recursion right here, where we'll do if take a token T equals tokens cur token if T.type equals, it'll need to be a number. The next token after this plus symbol will need to be a number. Otherwise, we'll return 0 and say printf error number token after plus. We'll do processing error plus plus. if token type equals number, and then we'll look ahead to the other one. We will do if. I'll need to get the token count straight here. Token plus. We can do another binary operator. Oh God. Yeah. We'll sum up the current value. Value plus equals t dot data dot integer. And we'll feed in the value again. And we'll just keep going deeper and deeper. But now we need to figure out the token that we're at. I'll just run the code and we'll step through it. I lost the whole structure, so put a breakpoint right there. We'll compile it, make sure it runs. We'll do integer, let's do +1 +1. Int test +1 +1. Peak token, binary operator, current token is 3. We started with int is token 0. I am in first year in college and we do C like they have to teach us Python first because it is easy. Yes, Python is a great language to learn first. I learned Python first when I was going to college. And it's simple. It's basically like writing pseudocode. And I'm sure they've said this, like Python is basically pseudocode. And C, like once you can grasp Python, it's easier. Yasin T6H. I'm having problems now with C and algorithms. Yeah, I mean, of course, when you're learning. I mean, everyone has problems with C. No one knows everything. If you're having problems, there's a bunch of textbooks you can read. Like, again, I mentioned this earlier in the stream. Check out Handmade Hero. You can Google it. You'll learn everything you need to know about C. If you want to know about language design, you can go to, not here. Did I close out of it? I think I closed out of it. Where is it? Crafting interpreters. You can go to crafting interpreters to learn more about language design that we're doing right now. It starts in Java and then it goes to C. You can talk to AI like ChatGPT. It's a very fast Google search and you can ask it, how do I do this in C? But you don't want to copy and paste the code. You want to talk to ChatGPT and, oh hell, let's just open up ChatGPT. ChatGPT. Of course, I use it a lot just because it's a very helpful tutor. How do I write an AST parser in C? 3-stage pipeline, Lexer, where you break it down to tokens. I think we have that parser tokens into. Okay, well I got it backwards. I think we wrote a text Lexer in C. Semantic passes, name resolutions. So then it tells you like, yeah, you can do prat parsing, you can do ASTs, you can look for all these tokens. I think this is oddly similar to crafting interpreters. They must have, I mean, you know, when they design these things, they shove everything written on the internet into it. And so there you go. So, of course, it's going to be wrong. It's going to get some stuff wrong. But what you can do is if you're having difficulty in C for school, you know, you can go like, how do I do this? And then it's like, okay, type def, enum. You know, it's like doing it the hard way. Like learn C the hard way. Learn C the hard way. And it's a book written by Zed Shah, I think. Yeah, Zed Shah. And he just shows you what to write. So you can just, with AI, this is just one of the methods you can learn, but you can do like it. Learn the hard way, where you see the code, and then you write it out, blah, 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 blah. And then you run it, and then you debug it, and then you figure out how it actually works. You don't want to do this. This is what you absolutely don't want to do. It's like, oh, okay, AI gave me this code. Okay, yeah, let's do that. You don't want to do that. You don't want to do that. You want to write it all out from yourself, from scratch yourself, and then step through it with the debugger. We're not going to do that right now. We're just going to finish up this feature. Sorry, people. I keep getting distracted. I love to explain stuff. Man, the stream is back in computer enhanced. I'm way behind. No, I'm not live. Okay, yeah. Okay, so anyway, we stepped into the binary operation because we see that we have a plus symbol. Of course, we can do like a little branch here where if we have a minus or a multiplier or a slash, and then we would need to do precedence. We're only going to handle plus for now, and then we're going to end because my voice is getting mighty sore. So we are at token 3. We'll step into this. T token's current token. This will be the number token, which is 1, 0, 1, 2, 3. Okay, so we already read that. And so we want to do current token. If peak token, like increment it, that will be the plus symbol. We can just throw that away and increment again, and that'll take us to the number symbol. So if the current token is a number symbol, then we'll add that. And then if we see that it's a plus, t.type tokens, cur token. I guess we should make this a pointer. Because once we step out of this, well, no, we don't really go any deeper beyond that. So yeah, it's fine. It's fine. We'll just leave it broken. Who cares? T.tokens. .type. Do a little plus plus. We'll just keep going deeper and deeper. How about that? Okay. So, 1 plus 1. Step into it. What is the current token type? It should be a number, yes. Token number. This is going to be a plus. Oh, it's not a plus because... Let's do that again. One more time. Oh, God. I pressed enter immediately, and hey, it read end of file, so that actually works. That's cool. Peek the token. It's a plus. Do all that. The next token type is a number. Value is now going to be 2 because we added 1 to 1. We're going to check the next token. Current tokens. What is 6? This is going to be the end of file. Yes. Yes. Okay, so we're going to exit. And we assign 2 to the test integer. Wow, look at that. So can we go deeper? Let's go deeper. Let's see how deep we can go. Let's do 1 plus 2 plus 3 plus, please, plus 3 plus 4. I can't do basic math. Assign 3 to integer test 3. Okay. That's not right. 1, 2, 3, 4. Peak token. It's going to be 3. Current token is 6. There's plus. Yes. Good. Oh, that's because I don't do value. Yes. Okay. Got to assign the result to the value. 1 plus 2 plus 3 plus 4. That's going to be... I can't do basic math anymore. That's 3 plus 3 plus 4, which is going to be 10. And we assign 10 to test. So that is wonderful. Broken abstract syntax tree, and we can only add numbers. Oh, God. Plus 5, plus 6. This will give us 21. 21. Okay, cool. So we wrote a broken language. We can assign to integer. We can assign a variable to an integer, store it in a hash table, and we can very badly recursively add numbers together. So just as a little introduction, you don't want to do this. You want to instead read the brilliant crafting interpreters. Of course, I gave you everything you need to get started. He does it in Java, But if you write a hash table like this, push stuff into it, and you design your recursive descent syntax with like expressions and then different types of expressions, you can do everything he can do in C instead of in Java. But of course, if you're more familiar with Java, you can do it there. But there you go. I gave you all the starting tools. I'm going to brush up on it and figure out how we can do a full implementation of an abstract syntax tree, and I'll do that tomorrow. I'll work on it tonight, make it fresh in my head, and then I'll give you a little walkthrough on that. But I don't even know what the point of this was. This was just to see if we could, and yeah, but it doesn't work. So yeah, if you're curious, check out Handmade Hero and Crafting Interpreters. That'll make you way better. But that's all I'm going to do for now. I'll see if I can get back tomorrow. I'm just going to be spending all week on language design because I'm interested in it again and I want to remember how it works. And the eventual goal would be to take some kind of C-like language and break it down into this virtual machine that I wrote last year so I can have the full stack set up. Like, the eventual goal is to be able to take some high-level language and break it down into this assembly-like code that I can then plug into my virtual machine. So just want to write a full stack pipeline, and we'll be back on that eventually. But until then, thank you so much for tuning in, everyone. I really appreciate it. 4 viewers, that is insane. Most viewers I've had. So